Now, we saw pretty early on in this course that we singled out one special predicate, namely identity. And I want to give a brief overview of why we've done this, how useful it is, but also of the fact that it is a little bit arbitrary to treat this along with our quantifiers and our other truth functional operators like the Boolean connectives and the conditional. Now that we've introduced all the symbols that our language uses, it's time to look back at this special predicate identity, or equals. So to recap, we have an infinite supply of constants, a1 through an infinite supply of predicates of as many places as we please, an infinite supply of variables, plus our variable binding quantifiers all and some, and the familiar Boolean operators, plus the conditional signs. But we don't have anything corresponding with the English is, and we've noticed this because we've had to translate all f's or g's as everything, if it's an f, is a g, and some f's or g's as something is an f and a g. And there's no is here. We're treating these as compound propositions built up of atomic sentences. And we also don't have anything like is identical with. So we've just taken this is identical with, made this our equals predicate. So we've picked something from our stock of predicates and made it a two-place predicate that expresses that the two arguments it takes are identical, and we write this as A equals B. Now, why do we isolate this one predicate here when we have such a huge stock of predicates that we could have also picked, for instance, cube or large, or even such interrelated predicates as larger and smaller? Well, there are two general reasons for this. The first is that we want to be able to express things like that there are at least two of something. In order to do this, we have to cobble something together with our existence operator plus a negation of the equal sign. So we'll see multiply quantified sentences like this in a later lecture, but the point is that if we want to say at least two things are f, we have to be able to say that something is an f, something is an f, and that those two things are not the same. So at least in logic, we want to be able to make these kind of statements, and that requires equals. The other thing is that every other language that builds on what we're doing here also incorporates equals. There were optional videos earlier which discussed the first-order language of arithmetic and of set theory, as well as the language that's used in the calculus of functions, and these all incorporate this sign, equals. So we just make an exception for equals. It's a special kind of predicate. We need it. And so we add it in here at the bottom to our stock of items in our language, even though it really belongs up here, but we're isolating it because we want to treat it separately because it has these interesting properties. And that's why we need the identity sign or the equal symbol.